Okay, let's work through the examples you folks did in a group work today. So the first question concerns these two population groups. In the 20 to 30 group, there's a 1% incidence rate, while in the 40 to 50 group, there's a 6% incidence rate. And you start off with the idea that there is a male aged 24 tests positive, and you want to know the probability that that positive test result indicates the existence of this condition. So in the problem, we're looking at condition B. This is the hypothetical example we're considering. So if you have a positive test result, what are the odds that you actually have the condition? And you're told that the test is 89% accurate with a 7% false positive rate. And 4% of the time, the other 4% of the time, it's inconclusive. So here's how we can use those numbers. We pick a random sample of men of this age. This is their age. And then we know that 1% of them have this condition. So that would be, we would expect 1,000 to have B out of 100,000. So we would also expect 99,000 to not have this condition. Out of this 1,000, we expect 89% to be detected. So that's 890 have B and receive a true positive result. The test picks up on it. Let's not worry about this stuff. Over here, out of the 99,000 who don't have it, 89% of them have a correct diagnosis. So what's 89% times the 99,000? Well, it's 88,110 don't have B and receive a true negative result. Right? And then over here, there is a 7% false positive rate. So 7% of those 99,000 is 6,930. Don't have B, but receive a false positive. Now, if we want to figure out the odds that a positive test result indicates the presence of B, then we need to look at all the positives, which is 890 plus 6,930. So what's that? That's 7,820 positive results. So it might help to consider the idea that if you tested 100,000 men, 20 to 30, that you would expect to have about this many positive test results. Just imagine those positive test results all stacked up in a pile of papers. These are all positive test results. They're all positives. So you've got 7,820 of these. You know that some of them aren't true. The test is not 100% accurate. It makes mistakes. So some of these are false. Some of them are true. how many are true? What fraction are true? Well, we know that we expect out of 100,000 individuals in this group to be tested, we expect 890 of them to have a true positive. We know there are, on average, 1,000 that have the condition, but we know we're not going to get them all. We're going to miss some. And it may be that 110 of them get a false negative. It may be that some of them have inconclusives. So this branch here, we're not sure about. But 890 out of this ends up giving you about 11%. So this means out of this stack of over 7,000 positive results, you only expect about 11% of them to correspond to individuals who actually have the condition. Right? Okay. So let's do this again, but for the higher risk group. That was another question. So let's redo it. Now it's going to affect several places. It's going to affect these numbers. If more people in the men aged 40 to 50 have this condition, there'll be more out of 100,000 that have it and less that don't. This 89% and 7% will stay the same, but it will change the numbers down here. Let's see how that works. So we take our 100,000 and we take 6% of that who have it and 94% who don't. So this is 6,000 have B, so 94,000 don't have B. And out of this 6,000, we still expect 89% of them to test positive. That's 5,340 true positives. All right? Now over here, if we're only interested in positives, we still have this false positive rate of 7%. Now it's 7% of 94,000. It's still a big number, but it is smaller than before, and it gives us 6,580 false positives. So in the age group of men 40 to 50, we would expect a total of 5,340 plus 6,580 test results. So that's a total of 11,920. So again, kind of going with that metaphor of papers being stacked up, all these positive test results. We expect out of a group of 100,000 men in this age group that there are going to be almost 12,000 positive test results. And then the question is, how many or what fraction are true? Well, there are 5,340 true positives. These are all the positives. So the ratio then ends up being about 45%. Now that's still less than a coin flip, but it's certainly a lot more than it was previously. So previously, for this low risk group, we might call it a low risk group, it's fairly rare, the tests gives us almost 10 times as many false positives as true positives. And so this risk group doesn't have a lot of faith in the exam, as long as you're asymptomatic with no other reason to believe you have it. Whereas over here, in a higher risk group, we expect there to be more true positives, almost as many as false positives, and so we have a greater confidence in the meaning of the exam. Now, the relevance of this stuff, as we'll talk about later, comes up when you talk about screening entire populations. There certainly have been suggestions, and in some countries they screen many or all people in certain segments of the economy or military for things like HIV. And the HIV test is exceedingly accurate, the two tests they use, but if you're scanning lots of low-risk people who practice safe sex, heterosexuals, non-intravenous drug users, then even with a highly accurate test in a low-risk group, you're going to expect a lot of false positives. So we'll look at that example at some point. But it's these things that play with the resulting probability. The odds of you having the condition depend upon so many things. They depend upon not only the accuracy and the false positive rate, but also the incidence, the frequency that the disease occurs in your population.